Very happy to be here. So I'm Seth Grae. I'm the CEO of Lightbridge Corporation. I'll share hopefully the correct screen here. And okay. So at Lightbridge, we are developing advanced fuels for existing and new water-cooled reactors. This fuel is designed to work in all of the light water reactors in the world and the pressurized heavy water reactors, as well as the smaller versions of those that are being developed. We see the advantages of what we are developing as helping to allow nuclear power to really reach its potential for significantly helping meet the climate needs of the world, the energy needs, and to help wean allies off relying on fossil fuels from Russia and others that don't have their national security interests in mind. This is our safe harbor statement. We're a publicly traded company, so I'll just call your attention to that. We're one of several publicly traded pure nuclear companies, which is sort of a new thing that investors can look at very different companies in nuclear that are pure nuclear and publicly traded, and more coming that are in the process of going public now. We're on the NASDAQ. And what we've done is really, for the first time since the light water was invented and deployed over 60 years ago, reimagined and redesigned the fuel from scratch. There are always slight incremental changes to the pellets in the tubes, but we've taken modern engineering, modern metallurgy, modern technology, both on the design and the fabrication side, and have come up with something very different, working closely with utilities, looking at what they were looking for and improving the economics of current and new reactors, in particular by lengthening the fuel cycle and by more power output from the existing reactors, and have come up with a fuel that meets those demands and others, and we think will in many ways be very helpful for small modular reactors in large-scale deployment around the world. This is a much more proliferation-resistant fuel that will matter for deployment in numerous countries around the world. It will improve the economics of the SMRs. This fuel will run about 1,000 degrees Celsius, about 1,800 degrees Fahrenheit cooler down the center line of the fuel than current fuel in reactors, and that relates to some of the very significant safety advantages that the fuel will bring. This is a picture of a mock-up of a fuel assembly. We are designing for many different types of reactors. This is for a Russian VVER type reactor, a variant of a pressurized water reactor. And the fuel is optimized, the fuel rods, for each different kind of reactor. So for example, on this next slide, you can see one of the rods we designed, and this went through some testing. Now, this is a cross-section of one of the rods for a VVER, where we have 3 lobes. For a PWR, a Western, say Westinghouse type reactor like Seabrook, this would have 4 lobes instead of 3, would look more like a plus sign. One of the many benefits that we've designed for is no spacer grids. So to hold the rods together in the core of the reactor, there are no grid straps, no spacer grids that block the water flow. So that is what's partly responsible for the power increase, that the water just flows much more unimpeded up from the bottom through the top of the fuel assembly and around again. This shows the temperature difference down the center line of the reactor, some of the safety benefits it brings. That link on the bottom right is current on the US Nuclear Regulatory's website, what the NRC says about this fuel. includes, and this is on its website right now, a significant increase in fuel thermal conductivity compared to ceramics, promotes lower operating temperatures, complete retention of fission products, means no burst release of these products upon cladding failure. No one else will be able to provide that, in addition to safety features for the reactor that also helps with radiation exposure for plant employees. And doing all this while actually bringing higher power and longer fuel cycles to the reactors. We have designed the fuel and patented it. We've also designed and patented the manufacturing methods for this fuel. I'll only pick out a few things on each slide, and we'll get to your comments, questions later if there's anything you want to focus on. As you know, the capacity factors are very different for different energy sources. The renewables are quite intermittent as the wind blows and the sun shines. Nuclear has the greatest capacity factor. Think of capacity factor as if the plant can run at 100% of the time, 24 hours a day, every day of the year. Fleet-wide, nationally in the United States, nuclear is about 92.7%. Some of the reactors are over 95%. And virtually all of that downtime is planned years in advance for the spring or the fall when the power isn't needed as much and the reactors can be refueled and have maintenance on them. But the utilities want to increase these capacity factors more, including the ones that we've been working with. And by lengthening the fuel cycle, and by actually with this fuel allowing a much quicker ramp up from an outage to full power and a much quicker ramp down that you can't do with the pellet and tube fuel that goes up and down in power very slowly. This also increases the capacity factor of the reactors by getting it up from that outage so quickly and then back down into the next one. And the next outage will be 24 months later instead of 18 months later. So the reactor is running for quite a bit of time that it would have been shut down for an outage. Some of our recent fuel development milestones are really centered around that. If you want to get ahead in nuclear in the United States, you really need to partner with the US government to access facilities, materials, and receive funding support. And we announced in December a long-term strategic partnership project with Idaho National Laboratory and the US Department of Energy. We are now manufacturing fuel coupon samples that we will irradiate in the Advanced Test Reactor at Idaho National Lab, and the data will support the fuel performance modeling and regulatory licensing efforts at the Nuclear Regulatory Commission, as well as at nuclear utilities and fuel fabricator companies. And under this work at INL, there's just about every quarter a new milestone being announced by Lightbridge, and this is leading to other developments on the commercialization path to the fuel. The fuel can be used in all the variants of pressurized water reactors, boiling water reactors, and as we're going through this testing program at the Advanced Test Reactor and also at the Treat Reactor for transient testing, including accident type testing, that's helping to guide the commercialization path of which types of reactors exactly first and which reactors, even within those groups, are being prioritized for first commercialization. So the top photo here is the canal at the Advanced Test Reactor, and paths that will come from this are the pressurized heavy water reactors like CANDUs, the small modular reactor, light water reactors, both pressurized and boiling water reactors, and the existing large reactors and new ones being built in several countries. And they all have advantages for why this fuel might go into them first. For example, to use the fuel in the CANDU reactors, we would not be using HALEU. We'll use enrichment of uranium higher than the CANDUs now use, but not high assay, low enriched uranium. So for CANDUs, we don't have to wait for commercial supply of HALEU. We will bring the benefits of HALEU and advanced technologies to the light water reactor, SMRs, and the large existing reactors, but that supply of HALEU is not commercially available yet. But the US government, working with allies, is very seriously working towards solving that problem and having more enrichment in the US and in allies available in the coming years. And in particular, there's a demonstration project at Centrus in Ohio happening now, another pure nuclear publicly traded company, and Urenco at their plant in New Mexico is adding 15% to their enrichment capacity, and they're looking into adding more capacity in their European plants. I'm glad to see the West addressing a lack of enough uranium enrichment now that we either can't access Russian supply as much or don't want to. One of our new and growing collaborations with the US Department of Energy is that we have a nuclear energy university program grant of $800,000 from DOE to MIT, under which MIT is studying accident-tolerant fuels for light water-cooled small modular reactors and is specifically looking at simulating the performance of Lightbridge fuel for NuScale's SMR. And we're collaborating with NuScale and with MIT together on this. And the analysis is looking at promising advanced fuel forms to improve the safety and economics of light water reactor SMRs. And we're glad to see MIT, DOE, and NuScale all recognizing Lightbridge fuel for that. We have a second new nuclear energy university program grant from the DOE as well, $1 million to Texas A&M University that we announced about a month ago, that will also simulate Lightbridge fuel in NuScale's SMR, and more specifically looking at the pressure drop correlations I mentioned at why the Lightbridge fuel will improve the economics of SMRs, we believe, quite dramatically. And this program also helps train the next generation of engineering students to use advanced multi-scale, multi-physics simulation tools. And we're glad to see them learning that in relation to Lightbridge fuel in a NuScale SMR. We first came up with the concept of this fuel in 2010, working with utilities, and have gone through some of these major steps shown on the chart here. What's not shown on the chart, of course, is, in 2011 was Fukushima. That really derailed a lot of things in nuclear. We lost access to the Halden reactor where we had planned to do the testing. And when it shut down after Fukushima, and then we lost access to the NRU, the National Research Universal Reactor at Chalk River in Canada, where, like Norway, Canada shut down its research reactor in the years following Fukushima. In 2014, Russia invaded Ukraine and seized Crimea, and we lost access to work we were doing in Russia. It looked like that might come back, and the US government might possibly even support that when, in 2022, Russia invaded Ukraine again in a much bigger and worse way. And now Russia is, of course, completely off the table. But in the interim, the US government has stepped up. And Lightbridge, like other US nuclear companies, has benefited from it. So the advanced test reactor and the treat reactor have now become user facilities that industry can use, and we are. And nuclear materials like HALEU for testing is being made available by DOE, and other materials, other equipment that we just can't access in the private sector. You can't get high assay, low enriched uranium in the private sector. You can't get access to the advanced test reactor equivalent in the private sector. It doesn't exist other than in Russia and China. And for China, we don't have access for political reasons also, and don't want to. So we're glad to be part of the US effort to advance nuclear technology. And Lightbridge, we believe, supported by the DOE and its national labs, will play a significant role in the global energy transition, as I mentioned earlier, really helping the SMRs and the existing reactors powered by this new fuel really meet their potential. And the Lightbridge fuel will bring to these SMRs the same benefits that we bring to large reactors, but we believe, and this is what some of the studies that are going on now we think will show, that the benefits to SMRs will be even greater, including, say, for those pressure drop reasons. A lot of SMRs don't rely as much on the power of large pumps as on natural circulation, and not having spacer grids and grid straps and easier water flow, we think will make the Lightbridge fuel even better for SMRs than for the existing large reactors. But we're glad to see, I think in some surprising ways, more large reactors being ordered and built in the world than a lot of people had expected. I think it's not going to be just SMRs going forward, although that might be the case in the United States after the next Westinghouse plant at Vogtle, the next EP1000 opens a few months from now. There might not be another new large LWR built in the US for a long time, but I think there will be in many other countries, is what we're seeing, as well as the SMRs here and abroad. And we expect to bring our benefits to those plants. The small modular reactors, including this image from NuScale of its Voyager plant, we think really have the potential to be deployed in very large numbers. And these include the SMRs being developed by GE Hitachi, soon to be GE Vernova, as well as Holtec, and others that are developing light water reactor SMRs. And we're carefully following what they're doing, making sure that our fuel is being designed to bring significant benefits to these types of SMRs. Lightbridge is not designing a reactor. Lightbridge will not deploy a reactor. Lightbridge is just about designing and manufacturing fuel. And we do intend, we are looking into manufacturing these fuel rods ourselves, although we could also license the technology to companies in other places, or we could potentially produce fuel rods ourselves that are then assembled into fuel assemblies and fuel bundles by existing fuel fabricators that might want to have their own IP on the top plate, the bottom plate, other aspects of the fuel assembly beyond the fuel rods that Lightbridge is designing. And, I think that there's sort of a rollout. No one is sure of the chronology, and, some of these will overlap with each other, and many different reactors within each group will be different. But the existing reactors are kind of unique in that they're an existing market of about 400 reactors around the world that could use Lightbridge fuel. If you're developing a new advanced reactor, you don't have anything around the world that could use your stuff. You have to have a new reactor built. Lightbridge has a big existing potential market as we qualify this fuel. And then going into the light water reactor SMRs like NuScale and the GE Hitachi BWX300 and Holtec and Rolls-Royce and other SMR developers, we think that because these are pressurized water reactors and boiling water reactors have a lot of existing supply chain, the regulators like the NRC understand light water reactor technology, that I think these will be deployed in larger numbers sooner than the next category of the advanced reactors that are being developed by companies like TerraPower and X-Energy and Oklo and others, and we look forward to seeing these plants as well. But I think having large numbers of those deployed around the world with regulators understanding them will probably take longer than the existing light water technology that has been licensed for over 60 years. And then in the future, eventually, fusion, although I really don't see fusion as being commercialized at a large scale to help with the energy transition materially before 2050. But we think the Lightbridge fuel for these first two categories of the existing large reactors and the SMRs that are coming, the light water SMRs, will have a very significant role to play. This ramp rate for SMRs can be very important for points other than just economics of coming out of an outage quicker and going into an outage quicker, and therefore having more revenue from selling more power. That right now reactors are terrible at load following for a lot of reasons, including that the pellet in tube uranium dioxide fuel really can't surge down in power or surge up in power quickly. You'll crack that fuel rod if you surge it up in power quickly. But we believe we'll show that you can with Lightbridge fuel and in an SMR plant where the other systems are designed to take those increases and decreases in power. And we've already done some things that give us great confidence that this will be the case. So, we'll talk a little bit more in the next couple of slides about coal to nuclear, but really we're also getting to natural gas to nuclear. That if we're really going to have an energy transition and get off emitting CO2, the natural gas plants are going to have to go eventually too. And right now, one of the biggest drivers for natural gas plants is backing up renewables. In fact, in a lot of places with renewables, there's more power provided by natural gas than there is energy provided by renewables because of the intermittency. And if we're going to get to zero carbon grids, I think we'll eventually see SMRs replace those natural gas plants, with Lightbridge fuel really being a key, because unlike the current fuel the SMRs could use, the Lightbridge fuel can surge up and down in power quickly, like the gas plants can, as the sun doesn't shine as much and then comes back from behind a cloud, or the wind doesn't blow as much and then comes back. And the SMRs could really go up and down in power and load follow on a zero carbon grid with renewables like natural gas does now. We also think that customers with SMRs will apply the Lightbridge fuel powered plants in many ways. A very efficient SMR can be used to decarbonize difficult to decarbonize sectors with zero carbon hydrogen-based liquid fuels and fuel cells. And we see these being used by people with SMRs in aviation, shipping, cement and steel production, heavy trucks, trains. And if we don't decarbonize these sectors, we're not going to decarbonize as much overall. So we really need to bring nuclear benefits to all sorts of energy areas, not just electricity. And this coal to nuclear transition, and that I think also will lead to natural gas to nuclear transition, is very interesting. The Department of Energy published a study in September that showed 80% of the retired coal plants have the basic characteristics to serve as sites for SMRs. 190 sites around the US. If you put an SMR on each, that will be almost 200 gigawatts of electricity, which is twice as much nuclear energy as produced in the US today. So if we put an SMR on each of these sites, it would triple the amount of nuclear energy in the United States. It would be a great market, we think, for Lightbridge. And it would really help with decarbonization. We talk about infrastructure on these sites, and sure you've heard these from many others as well. There's the electrical switch yard, there's the connection to the electric grid, there's not the need to build new transmission lines like there is with renewables. There's a great opportunity for savings of putting a new energy source on a coal plant site or any fossil fuel plant site and using that infrastructure. And as SMR designs come along, there could even be SMRs that use the existing turbine at the coal plant and generator at the coal plant, in addition to the electrical switchyard and the grid connections there. We believe there are compelling economics around Lightbridge fuel. There are about 419 water-cooled reactors around the world that we believe could use our fuel that are operating now. There's, 93 of them are operating in the US. When we think about this in terms of levelizing to, say, call a standard plant 1,000 megawatts, a gigawatt, you could think of that as about 100 of those in the US out of about 400 in the world, with about 400 gigawatts electric in the world. And the annual fuel spend for a reactor is about $40 million. So the total US addressable market is about $4 billion in fuel spend per year. And worldwide is about $16.7 billion a year in fuel spend. And we think that's something that will rise quite significantly if nuclear is to meet its place on helping with the energy transition. These numbers derive from a study that Siemens did through its subsidiary Pace Global and some analysis from Lightbridge on what a typical 1,100 megawatt, like Seabrook Westinghouse four-loop PWR would benefit from using Lightbridge fuel. And this is using the wholesale power price looking back 10 years, the average that it was over the last 10 years. And that'll vary by place, by time, but that's what this is based on. And just from Lightbridge fuel can be used in many ways. You could operate an existing reactor by 17% and not lengthen the fuel cycle, or you could operate the plant by 10% and increase the fuel cycle from 18 to 24 months. On a new build PWR, you could increase the power output by 30% for the same size core of the reactor with Lightbridge fuel. So these numbers are based on a typical 1,100 megawatt electric Westinghouse type four-loop PWR that's uprated 10% and has the cycle lengthened from 18 to 24 months for the fuel cycle. And this is what most of the utilities tell us is where their interest lies. So from that 10% increase in electricity production on an annualized basis, that would be about a $48 million benefit to the reactor. From increasing the reactor operating cycle from 18 to 24 months, from operating the reactor on days when it otherwise would have been shut down for an outage and selling that electricity, that's about another $8 million a year. And then just avoiding the cost of the outages, going from an 18 to 24 month cycle avoids one outage every 6 years. And outages are expensive. There could be thousands of guest workers at the site and other costs of the outage. It annualizes to about $4 million a year. So that's about $60 million a year of benefits from switching to Lightbridge fuel, we believe. And those don't even include the added economic benefits of any carbon credits that we believe will be available in many places, from switching to a zero carbon source and available to existing zero carbon sources in some places in the world. And coming, you'll see under the European taxonomy and in the UK and other places. And it also doesn't include the benefit that utilities often have to buy replacement power off the grid to supply energy to their customers during outages. So we think the economic benefits of Lightbridge fuel can be quite significant and provide the utilities with what they're looking for to help keep the existing reactors operating and profitable and justify the case for deploying large numbers of SMRs, where we believe these benefits will scale down from here, but proportionally be even better than for the large reactors. And the world, as you know, is having increasing demand for energy. The demand is coming, as you know, from many sources for electricity use. It's coming from the switch to electric vehicles. It's coming from data centers. It's coming from AI. It's coming from tax breaks and other incentives to switch to electric vehicles and other ways that decarbonize. And I think that nuclear power is going to be essential. We will not meet these increasing electricity demand without nuclear power significantly increasing, creating a great opportunity for Lightbridge. How much will nuclear power increase? Well, the Nuclear Energy Institute says that globally we'll go from about 400 gigawatts electric of nuclear power today to add 800 gigawatts to that, to about 1,200 gigawatts by 2050, a tripling of nuclear power in the world. Our estimates from looking at what the International Energy Agency and others are projecting for global energy needs by 2050, we think show that we're going to need 15,000 gigawatts electric, if not more, by 2050 of new clean energy in the world. And if nuclear were to provide a third of that, would be 5,000 gigawatts. That would be the equivalent to 5,000 large reactors added to the world by 2050, or a lot more than 5,000 small modular reactors. Now, what will the number be? Will it be 800 large reactors equivalent? Will it be more? Will it be less? We don't know, but we think there's a potential for it to be tremendous. We think there's a potential for it to be far greater than the NEI projection of 800 added gigawatts electric. We think that SMRs can be made, in mass production, like Boeing produces 737s and Airbus produces A320s in factories, and then they're delivered to sites where you don't need the complex work of building an airplane. You need the work of building an airport. And similarly, if we can get to civil construction on the site, like at a coal plant, but most of the SMR is assembled in a factory and shipped, I think the numbers can just be tremendous. And how tremendous? Can we get into the thousands or more? I think we can. In 1939, the US produced fewer than 3,000 military aircraft. On December 7th, 1941, we were about at that pace when Japan bombed Pearl Harbor. And the next day, the US entered World War II. And leaders of Japan and Germany were shocked. They did not expect that US industrial capacity could ramp up so quickly on such a complicated thing that seemed to make. The airplanes in the US went from being hand-built by craftsmen to factories, assembly line production, in some cases using Ford Motor Company sites where had assembly lines and made cars that were converted to aircraft. We produced in the US over 96,000 military aircraft in 1944, the last full year of World War II that ended in 45. We produced over 300,000 military aircraft in less than 4 years. Just mind-boggling. So fast, such large production, and really with such quality of the aircraft that went to Asia and to Europe from the US. These aircraft are about the size of SMRs, of the reactors in the SMRs. They're about the size of a NuScale SMR unit, a NuScale module. And I just think it's quite possible that as the energy transition is shown to be more and more pressing by many reasons, including the indicia that everyone is experiencing, for it seems to be from climate change, there's going to be a tremendous opportunity for companies to mass produce SMRs as they get through their initial demonstrations that DOE is funding, and then have customers lining up to buy units. There's also bipartisan support for advanced nuclear energy that Lightbridge and other nuclear companies are taking advantage of. Some of this is being driven by Russia's invasion of Ukraine. Some of this is being driven by climate change. We're seeing governments in many countries and organizations comprised of governments moving very quickly from the European taxonomy to the UK, to Japan opening reactors that have been closed since the Fukushima accident and building new ones, the Inflation Reduction Act in the United States, the bipartisan infrastructure bill, just real, meaningful, massive amounts of money being made available by DOE, and Lightbridge is very happy to receive some of that in supporting our project. This advanced nuclear technology race, I think, among a lot of others that are producing new reactors and Lightbridge for new fuel for reactors, really poses unique opportunities for us. And the government is looking at critical infrastructure resilience through nuclear and small reactors, for military bases that couldn't be cut off if the grid were taken down through a cyber attack, through critical national infrastructure, like data centers that should be taken off the grid and put on bespoke, reliable power sources like SMRs. And the government is looking at 100-year relationships with other countries that the US can supply reactors to. 100 years from the time the plants are first planned to decommissioning the last reactor at the site can truly be 100 years. We're seeing dams in the United States that are coming up on 100 years of operation. And we're seeing nuclear plants that are already having licenses extended in some places around the world from 40 years to 60 years, and then from 60 years to 80 years, with a lot of the equipment inside the containment dome changed during that period. But these can really be 100-year relationships between the US and other countries, and of course support manufacturing and meet climate goals. The Nuclear Fuel Working Group report that I had the honor of working on a little bit with people in government had said the US was missing out on an opportunity of $500 billion to $740 billion over the next 10 years. But and that was based on what the Commerce Department said. But now the government is really stepping up to make sure that doesn't happen. And the US has a significant role to play internationally in nuclear. And, I think we've got a real chance to do it. And the Lightbridge field can be a real part of helping. And, I'll just end with this slide that has contact information. Feel free to reach out to us at any time at ir@ltbridge.com. We're always happy to hear from you. If you're ever in the DC area, let us know. And it would be great to hear if you have any questions or comments. Thank you.